Last time we spoke about the periodic table, and today we're going to talk about the mole and the consequences of that concept. So here is a periodic table, the organization of the elements by their number of protons, which is called the atomic number. Hydrogen with one proton is the first element there on the way left, atomic number 1. Helium on the way right, but in the same row, is the second element with 2 protons, atomic number 2, and so forth. And the second guiding principle of the periodic table is that elements that behave similarly chemically are placed in the same column. Lithium is placed beneath hydrogen because it's somewhat similar to it. Lithium with atomic number 3 is there right underneath hydrogen. And elements in the same column share common names, the first column being called the alkali metals. In addition to the numbers, the atomic number, which is placed typically above the element symbol, there's also a number quite often written below the element symbol, which I've enlarged here, 1.01 for carbon, for hydrogen, 12.01 for carbon, around 16, 16.00 for oxygen. And these numbers connect to the AMU, and we need to define the AMU exactly. So the AMU is defined exactly by this scale. It actually is all based on carbon-12, one of the most stable isotopes. And carbon-12 is defined to weigh exactly 12 AMU per atom. And the problem with this unit is that the AMU, which is a mass unit, is extraordinarily light. And we want a mass unit like grams that we can use with our, for describing our daily life. For example, this pen is around 10 grams. The cell phone is, 150, 200 grams. We want something like that. And so the question we ask is, if I had exactly 12 grams of carbon atoms, how many carbon atoms would that be? And the answer is 1 mole. So 1 mole of carbon atoms weighs 12 grams. And how do I think of that as someone who knows the concept of moles well? And I really relate it in my head to the concept of a dozen. And the example I mentioned in pure lead is this one. 1 dozen hummingbird eggs weighs 12 grams. So I want to consider 12 grams of hummingbird eggs. The number that I measure is 1 dozen. If I want to consider 12 grams of carbon atoms, the number that I use to consider that is a mole. So we count eggs by the dozen, we count atoms and molecules by a mole, and the mole is a huge number. I'll tell you what it is later. But it really is conceptually very much like the concept of a dozen. So let's look at carbon. You see it's 12.01. And why is that? Well, not all carbon is carbon-12. Most of it is carbon-12. But there's also a little 13 carbon, carbon-14, and so forth. And what it is on the average, natural carbon, which is carbon that's found on the earth, natural carbon, weighs 12.01 grams per mole. So if we have exactly the same number of carbon atoms as 1 mole of carbon-12, instead of weighing 12 grams, it weighs 12.01 grams. And this natural thing is called the natural abundance. (12.01 grams per mole) is called the atomic mass of carbon. You can see hydrogen is 1.01. So 2.02 grams per mole is the molecular mass of H2, because each H on the average weighs 1.01 grams per mole. 18.02 grams per mole is the molecular mass of water. 1 mole of water, whatever that big chemist dozen is, weighs 18.02 grams. And here, let me show you so we can put it on a scale. The numbers 1.01, 12.01, 16.00, when we're normally using chemistry, we think of in grams per mole.